Hi guys, in this video we are going to solve this problem towers. We are given n cubes in a certain order and our task is to build towers using them. Now when two cubes are one on top of other, then we can place this upper cube if the lower cube is greater than this upper cube. And we have to process this cube in given order. Now we have to tell what is the minimum possible number of towers. So total number of cubes can be up to 2 into 10 to the power 5 and maximum value a cube can have is up to 10 to the power 9. So let's first understand this simple input. Okay, so here order is important, like we can't sort, like they have specifically mentioned that we don't have to sort. If we can sort, then we can just do like this 1 2 3 5 8. Then we could have done like this 8 then 5 3 then 2 and then 1, and then the minimum number of towers would have been 1, but that is not the case here. We can't sort. Okay, now let's see this one. Okay, so initially we don't have any tower, so we can put this 3 as it is. Now this new cube, either we can place on an existing tower or we can create a new tower. But to place this 8 on an existing tower, this upper cube should be greater than this 8. But here no cube is like that, so we have to create a new tower. So this 8 is new tower. Now we have 2. So 2 we are going to place here, and I will explain later why. Then 1 we are going to place here, and 5 we are going to place here. So this will give total number of towers as 2. So that is our answer. Now let's see why we are doing like that. Okay, so initially like there is no tower, so we can put 3 like that. And in case of 8 also, like there is no option apart from other than creating new tower, so we can put 8 here. But when we have to insert 2, then like there are 3 options for 2. Either we can place it on top of 3, or we can place it on top of 8, or we can create a new tower. Now this creating new tower is not optimal if for 2 there is an option available. Now let's see how. So let's take this example. Say we are having an tower like say 8. Okay, now we have to insert a new tower, say 3. Now I will take 2 scenario. So if I insert in a new tower like say 8 3, and if I insert on top of it of existing tower 8 3. So now for 8 this can accommodate up to 7, like we can accommodate up to 7. This is its maximum capacity. For 3 it can accommodate up to 2. This is its maximum capacity. Now for this 8, like this is like at top of this, like this 3 is top of it, so this will accommodate up to 2. Now here total number of towers are 2, so if we take another tower here, then this will be able to accommodate up to 10 to the power 9 and even more than that, but in our case up to 10 to the power 9 only our maximum cube size will be. So you can see this 2 is same, and this 10 to the power 9 is greater than this at 7. So this is certainly better. So that is why if you have an existing option, then we are going to keep that only. We are not going to create another tower. So that explains like why we should not create a tower unnecessarily. Okay, now let's see why we should put this 2 on top of 3, not on top of 8. Okay, so same thing we can do here. Like if we put this 2 on 8 top of 3, then we will have case like this 3, then on top of 2, sorry, on top of 3 we are having 2 8, and like this 3 8 and top of 8 2. So for this tower 3 2 we are having like maximum capacity up to 1. So this can accommodate a newer cube of size 1, and this 8 can accommodate up to 7. In case of this, it can accommodate up to 2, and this can accommodate up to 1. So here this one and this one is matching, and in case of this is certainly greater than this 2. so we can say this is a better. Okay, so that is why whenever like we have to put a new cube, then we are trying to take the least possible cube size. So in this case, when we have to put like say this 2, then we could have put it on 8, but no, we are going to put it on 3 because it is least possible size that can accommodate this 2. Okay, and now this thing like getting least accommodative size we can do using set. So we can use this upper bound in set in C++ to get what is the just greater than element. So if you are having like 3 and 8, then if you use this upper bound for 2, then it will return us 3. Okay, so that is basically it. Now let's see how we can write code for this. Here I have declared a vector of pairs A, and this first value in this vector will be the value which we are taking input, and second is the index. Now I am taking a vector of pair because this value can be duplicate, so we can have cubes of same size. So if we are using index with them, like if you are using pair, then this will become unique, because in set we have to insert. So in set we can only insert one copy of an element. Now in this for loop we are checking whether there is an pair which is greater than AI. So if we are getting a pair which is greater than AI, so basically like if a cube is there which is greater than this AI, so then what we are doing, we are first removing that cube from this set, and then we are placing this AI on this in the set. So basically this is equivalent to saying like we are putting that cube on top of that existing tower. Otherwise we are increasing the number of towers. So in this count we are restoring the number of towers, and then we are inserting again this new cube, and at the end we are just printing the number of towers. So let's run this. Yes, we are getting correct answer. Now let's submit it. Yes, we are getting correct answer. So if you are having any doubt in understanding this solution, then you can ask me in comment section. And thank you guys for watching this video, and I will see you in the next video.